Hello, folks, and welcome to Rational Science, the only site on the internet that does physics right. Anyways, regarding extinction, all I can tell you, Mr. Musk says that the world economy is going to hell. He's a little worried about that. And so that's just food for thought, okay? But let's get on with our science critic. There's a fellow who made a video and he criticizes our site, our notion of science, our notion of physics. And I'm going to be addressing each one of his points. And the point he made, one of the points he made, and that I'm going to talk about today, is whether if you have a PhD, right, does that mean that you understand physics? And so let me put him on here. Give me a second. Okay, let me turn this fellow on. Here it goes. Listen carefully. The issue to be resolved in this rebuttal is, does having a PhD in mathematical physics imply that the individual understands physics?
Well, if you have a PhD, you're far more likely to understand the subject that you have a PhD in than someone who doesn't have a PhD in that subject. If you've got a PhD, that at least shows that you have a decent understanding of the subject, because you do need a decent understanding of the subject to be able to get a PhD.
Okay, so the question is whether you need a PhD to understand, or we can put it in different terms. We can say that a person who has a PhD, for example, in so called mathematical physics, right, whether he can understand things better than you or anyone else. And I take exactly the opposite view. Okay, here's my rundown of that. Okay, these are what I call the fallacies. Okay, first of all, I think it's easier for an 8-year-old to understand physics than it is for anyone who's gone through high school or college. And you might say, well, that sounds counterintuitive. And let me tell you why. Because, see, when you get to high school, when you get to college, they start feeding your brain. Okay? And when we come out of there, we come out believing, for example, right? I'll give you a good example. We believe that electricity consists of the flow of electron beads from one atom to the next. That is what hardwired in his brain. He's not going to change his way of thinking so easily. On the other hand, if you take a kid, 8-year-old kid, and you teach him the right way or you teach him a different way from the start, he's got no reason to believe then that the electricity is the flow of beads. So that's the key issue. Okay, it's that in high school, in college, they start forming our brains, and then it's very hard to get out of that. I know, I've been there, done that. Okay, so I call that the fallacy of authority, and that's what this is what it looks like. You have you could say Big Brother there, or someone with a big degree teaching you, and you learn by rote, and then you repeat what this fellow told you. You believe it in great measure because if you want to make a career, you do a career out of it, for example, physics, well, you're not going to get an advisor unless you follow the rules. And the rules is you have to suck up. Okay, that's the issue. And I don't know how you can get a degree unless you at least, follow the party line. Okay, you have to be able to recite the catechism. That's what it amounts to. I call that the fallacy of authority. Anyways, here you have some PhDs. This is what they believe. Here are some examples. Okay, they have proposed Big Bang, black hole, particle at two places at once, warp time. Now, how's that for people who have degrees? What PhDs, right? We're talking about the highest degree here. And if this is what they came out with, what does it tell you about them? And this is what you got to think about. So the way I look at it, degree does not necessarily equal to understanding. In fact, I think it's the other way around. If you have a degree, typically it's because you've been brainwashed in a given direction, and it's very, very hard for you to, come out of that. And so, just keep that in mind. When you go to college, They actually make you think in a given way, and it's almost impossible for people to come out of that. Then there's the fallacy of democracy, what I call the fallacy of democracy. This is what it looks like, okay? Everybody voting for a theory, and that's also more or less what's happening at the college level. You have all these mathematicians on planet Earth, and they vote for a given theory, and so people say, well, it's been proven because all these mathematicians believe in that theory. Okay, and so you have, theory. Someone says, a particle can be at two places at once, and if everybody votes for that because they've studied quantum mechanics, and you say, well, that sounds counterintuitive, that doesn't sound very rational. Well, they're going to say that what you have to do is take a course in college so that you're brainwashed in the same direction. So, yeah, you've got that situation as well. And then the last one is what I call the fallacy of tradition. Okay, and this is what that looks like. Okay, here it is. That's the fallacy of tradition. You believe in stuff because that's the way we've always done it. And a prime example are definitions. What people do with definitions is you'll see them here on comments that people make. And they go in there and they say, look, this is the etymology of the word. I don't care what the etymology of the word is, because those words were created a long time ago. Maybe they come from the Latin, from the Greek, from the Persian, who knows from where. And they had a certain definition centuries ago. We've changed many of those definitions throughout time. We've given new definitions to old words. That's happened, but all those definitions are really in the realm of ordinary speech. When you bring them into science, hopefully, you restrict their usage so that they don't cover everything out there so that you can't tell the difference between A and B. No, you have to make sure that you have a very crisp definition that you can use consistently. That's called rational, scientific. And the fallacy of tradition primarily relates to definitions, but it also the way we do things. One of the fallacies of tradition also involves, the fact that we have this notion of the scientific method of science that we have inherited from the 17th century, and we're not very willing to change that. We think we're on the right track. And it turns out that not a single mathematician who follows the so-called scientific method of the 17th century can tell you anything about gravity. They cannot tell you anything about magnetism. They can't tell you what electricity is. They can't tell you how the atom behaves. They can't tell you what mediator we have for light. In other words, they can't tell you anything about the invisible, intangible entities and mechanisms that Mother Nature and Father Universe use out there. But they've been following the scientific method now, for 400 years? So they're not willing to change that. And in fact, I had a case this week. I was interviewed on Thursday by a fellow from England. And so I told him up front that I have a different notion of what science is. I have a different notion of what the scientific method is. And I told him up front that he would be shocked because I was going to delete from the scientific method, I was going to delete mathematics, and I'm going to delete also experiments. Now, he seemed to agree. He kind of liked the fact that I took mathematics out. He didn't give me a reason, but he seemed to like that. But when we got to experiments, he had big troubles with that. Okay, he said, you're going to remove experiments? I said, yeah, we don't need them. We don't do experiments in science. We explain them. And so I really put him against the wall on a given issue, on a specific issue. And I said, you have, gravity. You let go of the pen. I always do my little experiment here. Let go of the pen, and it falls to the floor. Okay? You can't see or touch anything below or above the pen. Correct? And so the question is, what experiment are you going to use, meaning see, touch, right? Eyes, hands. What experiment are you going to run to elucidate the first the entity that mediates gravity, and second, be able to explain it because you proposed an entity that we can see or touch. So there is no way, there's no experiment you can run to detect the invisible, intangible. The only way is to use the mind. You visualize and you try to imagine how Mother Nature, Father Universe, Devil, the God, whoever you believe in, how they could be doing this magic trick. Okay? There is no experiment you can run in the lab to detect whatever is causing gravity. And that's just one example. And so, I told this fellow this, and again, here we have the fallacy of all these fallacies come back: the tradition, democracy, and specifically, the one of authority. People believe in authority. This is what they've been drilled with in high school and college, and this is what they regurgitate, as again the party line. That's all it is. That's what it comes down to. And so this fellow, he had troubles with that. And what was interesting that we debated a little bit about some of the definitions, okay? And these are some of the definitions I found in his site afterwards. I checked his site, and these are some of the definitions he's got out there. And the two that were missing are the two most important ones, meaning he wasn't even on track on figuring out what are the most important definitions that we need, at least for the purposes of physics. And here, let me show you what definitions he proposed. What I want you to notice is that he mentions these words, specifically the word exist, but he never defines it. But so when I tried to define exist, he had a problem with that because it was contrary to what he believed in. He apparently was an atheist, and he had a problem with me saying that, an atheist was not a rational individual because an atheist talks about the non-belief of God, or that he doesn't believe that God exists. And that, I told him, is an irrational statement. It's an irrational statement because he doesn't understand what the word exist means. And physics is the science of existence. So that's how it all works. So here are his definitions. Okay? He says, believe, to accept something as true. So he uses words such as true, false. You'll find it in there. I underlined some of these. What is knowledge? Fact. Truth. Okay? He talks about reality. What is reality? Well, you look it up there, that right at the bottom. Reality means reality is that which exists. Well, unfortunately, reality is a synonym of exists. So he hasn't defined the word reality. What he's done is he put a synonym, and he goes around in circles because, again, he hasn't defined what exist means. So this is the issue. And one of the issues that was interesting about his definitions is that he referenced Ayn Rand. Ayn Rand, as some call her, I call her Ayn Rand. Okay, and the one he mentioned there are two that are really unimportant. They're not important as, for example, entity and exist. But he put in there concept. Okay, he said a concept is a mental integration of two or more units possessing the same distinguishing characteristics with their particular measurements omitted. They are isolated by a process of abstraction and united by a specific definition. Ayn Rand was very verbose, and she made nonsense of the word concept. The other one is reason. And the problem is that reason, she defined it, is the faculty that identifies and integrates the material provided by man's senses. Thinking is the process, logic is the method. So Ayn Rand thought that senses had something to do with reason, whether you're sensible, right? Whether you're sound, whether your argument is sound. And when you look up all these words, they're all synonyms: sound, sensible, reason, rational. They're all synonyms. So she never defined a word because she used synonyms to define them. Okay, you can't do that in science. Synonyms are outlawed because a synonym is a circular definition, or what I call no definition at all. Okay. And this is another one that he had here. This fellow suggested that there are things that we know, and I said we know nothing because know means to believe. When someone knows, he believes. He believes for sure. He's convinced of whatever he believes in. That's called knowledge. His knowledge could be different than my knowledge. So he gave me an example and he says, well, we know that water boils at 100 degrees. Okay? And so this is the example. He said water boils at 100 degrees. And there's a couple problems there. The first one is that I'm going to play devil's advocate. Okay? And I'm going to say, no, water does not boil at 100 degrees. And he said, no, let me prove it to you. Let me show you. Look, we put some water here. I heat it to 100 degrees and boil. And I say, I don't believe you. I don't know your knowledge. I disbelieve you. And he goes in there, no, but listen, let me show you. Let me prove it to you. Here's the truth. Here's the fact. And I continue to say, no, 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 and no. What's he going to do? Kill me? I mean, there are people who simply will not change their minds no matter what experiment, what proof you present, and they will continue to believe otherwise. And he didn't understand that. Knowledge is what one person has, okay? And so that's one issue. The other issue is that water boils at 100 degrees. That's not an explanation. That's a description. That's a prediction. He can say, look, I did it 100 times. Now I can predict to you and I can run an experiment where I prove to you that water boils at 100 degrees. So far, he hasn't explained anything. All he's done is describe what's going to happen. He hasn't told me why, what causes water to boil at 100 degrees. So I gave him a truth, a fact, a proof, right? The whole works. Something that's been confirmed by experiment. I said, look, NASA ran Gravity Probe B, what was that? I think 1971, okay? I think it was 71, 72, thereabouts. Anyways, NASA ran this experiment, and what was the conclusion? What was the physical interpretation for what they say is yet another confirmation of Einstein's theory, okay? What was the explanation? They said that the Earth drags time around itself. It's known as frame dragging, okay? And we got a little title for it because they're saying that with respect to a given frame of reference, right? Something changes. They had these two gyroscopes that changed their position out there, and they said, oh, we confirmed it and we proved it, etc., etc. And so I gave them that explanation. I said, look, NASA says that Earth, as it spins, it drags time around itself, which makes no sense whatsoever from a physical point of view, okay? Mathematically, we don't care. We're saying that the explanation they gave us is nonsense. And he says, well, I don't believe that. I said, what do you mean you don't believe it? It's knowledge. We've proven it through an experiment, like you said. And he said, no, that knowledge I don't believe. I don't believe NASA. So I mean, again, knowledge is what one person believes, okay? His neighbor doesn't believe it, okay? And he said, but my knowledge is justified. That comes from Plato, justified true belief, okay? And he said, but what if it's justified? What if I have a justification for having that knowledge? Okay? And I said, justified means belief. What is justified? Who justified it? The Pope? The Dalai Lama? I mean, who justified it? Justified means opinion, belief. So all he said is he believes his belief. That's all he said when he says that his knowledge is justified. So no, those people who insist that knowledge is different than belief, well, I want a definition. Don't tell me that knowledge is different. Just tell me what each one exactly means, and I'll be glad to tear it apart. Because to this day, we equate, we're still using Plato's definition. And that one it comes out as justified true belief. That's what knowledge is. And all they're saying is that your belief is justified. But what is justified to one human being is unjustified to another. And knowledge comes down to being equal, exactly equal to belief. There's no difference, okay? Experiment will not change that, okay? No experiment will change that. Okay, so what was this fellow's beef? Well, the problem was when I said that atheists are as irrational as agnostics and as deists or theists. Why are these three groups irrational? They're irrational because they never define the word exist. So they argue in circles. One guy says, I believe that God exists, and he presents all his proof. The other guy says, I don't believe that God exists, and he presents all his arguments and proofs. And the agnostic says, well, I don't know if God believes or exists or not. I don't know what tests we can run. I'm not sure what arguments they have beyond that. They have like several arguments. But essentially, it's a guy who hasn't made up his mind. He's on the fence. And I'm saying all these three individuals are irrational. Why are they irrational? Well, for that, we go back to Mrs. Ayn Rand, okay? Maybe she can clarify for us why it's irrational. Here's Ayn Rand's definition of entity first, okay? Thing, what is an object? What is a thing? What is an entity? She liked the word entity, no problem. We considered it a synonym, okay, of object and of thing. So where's the problem? Let's look at her definition. We'll find out. Here it is. Okay, she says entity, okay? And she says to exist is to be something. And we have a problem there. As you can see, she essentially was a pupil, a follower, whether she knew it or not, of David Hume and Immanuel Kant, who said exactly the same thing in the 18th century because they couldn't tell the difference between exist and a thing, or exist and an object. So she says, to exist is to be something. Absolutely not, but let's continue. As distinguished from the nothing of non-existence. It is to be an entity of a specific nature made of specific attributes. And this is where it goes wrong. I want you to listen to this because she essentially synthesizes what most people out there think a thing is, okay? The development of human cognition starts with the ability to what? Perceive things. In other words, entities. Perceive. It's that perception word that introduces the observer where we don't need them. And so she continues, says, of man's 5 cognitive senses, only 2 provide him with the direct awareness of entities, sight and touch. Exactly the ones that we kill. We say sight and touch have nothing to do with physics. Okay, we don't use sight and touch when we theorize. We have to kill the observer. We do it mafia style. Rub the witness out. That's the way it works in science. In order to perceive this something, he needs sight and or touch. Okay, so she's going to emphasize the observer. She's going to emphasize the witness. She says we need sight and we need hands, touch. We need eyes and hands. It is by perceiving entities that man perceives the universe. Okay, so she did emphasize that for entities, for things, what you need is eyes and touch. And what is eyes and touch? It's also exist. Because exist is defined exactly in the same way, not only by Ayn Rand, but David Hume and Immanuel Kant. Okay? And so we move to existence, which is what concerns us, because we're going to be talking about the atheists who say that they don't believe in God. We are looking at the deists and theists who say they do believe in God, and the agnostics who say that they don't know whether to believe or not. And this is what Ayn Rand had said about existence. Existence exists. Existence exists. Now, how's that for a definition? And the act of grasping that statement implies 2 corollary axioms. That something exists which one, what? Perceives. And that one exists possessing consciousness. Consciousness being the faculty of what? Perceiving that which exists. All she did was chase her tail around. If nothing exists, there can be no consciousness. A consciousness with nothing to be conscious of is a contradiction in terms. Okay, if that which you claim to perceive does not exist, what you possess is not consciousness. Whatever the degree of your knowledge, these 2, existence and consciousness, are axioms you cannot escape. Whether you know the shape of a pebble or the structure of the solar system, the axioms remain the same, that it exists and that you know it. Again, knowledge introduced together with existence and things. So she continues, she says, to exist is to be something. Absolutely not. As distinguished from the nothing of non-existence. The greatest of philosophers, she was referring to Aristotle, has stated the formula defining the concept of existence and the rule of all knowledge. A is A, A thing is itself. Existence is identity. No, all she said was nonsense. Okay, A is A. We talked about that the other day. Is absolute nonsense. The identity, the law of identity, and then you have the law of non-identity, which is A not equal B. I mean, it's all nonsense. No, what we do in science, we have to define what an object is, and we have to define what existence is. Once we define those words, we can start doing physics. Okay, and so some people confuse me with Ayn Rand, and those that do simply have not figured out how different my stuff is from what Ayn proposed. An object is that which has shape. Existence is physical presence. Physical means object, presence means location. An object that has location exists by definition. And as you can see, there's no provision in that definition. There's nothing in the specification of that definition that requires belief or an observer. If something if you have an object, that which has shape, and it has location, it exists by definition. If God wants to exist, first he's got to be an object, got to be a thing. And then that's not sufficient either. He's better have location. There had better be distance between God's chest and mine. There should be a straight line of direction between God and me, no matter where, no matter what dimension God wishes to hide in. Okay? So let's go with the conclusions here for this fellow. Okay. Conclusions, high school, college education. What is that? It's known as brainwashing. What they're going to be doing is you're going to be learning by rote. You read a book, maybe you even run an experiment at lab, it doesn't matter, but they're going to coach you on what to believe. Okay. And what's the problem? The problem is that all that's accompanied by irrational explanations. And they don't care about mechanisms. They haven't figured out any of the invisible, intangible mechanisms. They dismiss that as philosophy, as opinion. And I can summarize it by saying you can't teach an old dog new tricks. No, it's easier for an 8-year-old to understand, for example, what I'm proposing, okay, because his mind has not been polluted. So a little boy might be more predisposed to understand a new theory than an old dog, who's gone to high school and college, especially a PhD, who has to get an advisor for his thesis. That guy is not going to change. So I see it the other way around than this British fellow. I'm saying that if you've got a PhD, oh man, you've gone through the whole machinery. They've been conditioning you for quite a while, So if I go in there and say, look, I'm going to erase the scientific method that you inherited from the 17th century, he's not even going to listen to me. Okay, let's move on to the gut. What is the gut? The grand unified theory. What is known as the Holy Grail of Mathemagix, of mathematical physics. Okay, and here's, I guess, a rundown so that you can follow along. Okay, the gut, the Holy Grail of Mathemagix. Gut is what? The unification of light and gravity. You could also say it's the unification of quantum mechanics and general relativity. General relativity is the world of the big. We're talking about planets, stars, galaxies, and the big issue there is gravity. And then you have the world of the small, and that typically involves light and things like electricity, magnetism, which could also be applied, on a on a universal basis. Okay, so what is mathematical physics? It's equations followed by irrational mechanisms. Okay, not a single one of the mechanisms proposed by mathematical physics is rational. What is irrational? The movement of concepts. If you start vibrating the field, if you start waving the wave, right? If you start transferring energy or moving the mass, well, then it gets very, very dangerous, okay? So, we don't want to start moving concepts around. And that's what they do. And so that's what they're trying to do. They're trying to merge uh, light with gravity and general relativity with quantum mechanics. That's the Holy Grail. But what are they looking at? They're looking at an equation. They're trying to find this grand equation that underlies it all, that can describe it all. Because again, they're not talking about explanations, they're not talking about mechanisms and causes. What they're talking about is just a description, a numerical, a quantitative description. Okay? And that's what an equation does. It describes. That's all it does. So now let's say we have some entity out there. We'll call it what unidentified flying object. You like that one? A UFO. Okay. Its speed is 30 miles per hour. So what are we talking about? Are we talking about a turbo car? Are we talking about a galloping cheetah? Are we stretching a spring, a coil? You're looking at the front end of the coil. Is that what's traveling at 30 miles per hour? Or is it flowing water? Are we having a liquid flow there? And here, let me give you an example. Okay, here it goes. Okay, look at him. He goes everywhere. So what are we staring at? We're seeing what, a tornado there? What is that? So the first thing you need to identify is the thing that is moving. Unless you can identify the thing, what are you describing? Okay, this is the problem. And right now we don't have entities for the invisible, intangible mediators that Mother Nature uses out there. So the fact that you can tell me how fast your turbo car goes, or your galloping cheetah, or when you stretch a coil, it doesn't tell me which of these you are referring to, because the equation applies equally to any of those situations, in any of those contexts. So the issue is there, that you need to identify the invisible, intangible entities that Mother Nature uses. And that's what they've never done in mathematical physics. That's why we don't have explanations of mechanisms today. What we have is equations, we have descriptions, we have predictions, but we don't know what's causing it. And, for 3,000 years, people have asked the same question. What causes gravity? A little sooner than that, what causes magnetism? What causes electricity? I mean, what was Faraday investigating? What was Maxwell investigating? They were trying to figure out how this universe works. And by how, I don't mean a description like saying, oh, it works at such and such speed, or this is the acceleration, or whatever. No, they were trying to figure out what causes it. What are we staring at? Why does a pen fall to the floor? That's what they were trying to figure out. What causes that to happen? And here, let me give you a good example. Here we have the lines of force of a magnet, okay? And they say, well, this is what we call a magnetic field. Magnetic field is made out of all these lines of force, as Mr. Faraday told us. And so when you look at this, they say, they try to explain that. They say, well, those lines of force don't really exist. We use them just to give you some sort of physical interpretation of what's going on there, but they're not really there. So you have all these iron filings, they line up around the magnet, and they form those familiar patterns. And they say, well, don't pay attention to that, because those lines of force are not really there. And so you say, well, why does a magnet attract another? And they start talking about the field. They start vibrating in this concept. What is a field? It's a bunch of values, okay, that get weaker and weaker as they get radially away from ground zero. Okay, so we call that a field. And now they're going to vibrate these numbers, and they say, well, all these fields vibrate. And even with that, they cannot explain attraction, because tell me how that magnet attracts the other one. That's what I want to know. Okay? And so when we go and we look up Mr. Faraday and Mr. Maxwell, this is what they tell us. This comes from Faraday on the physical characters of the lines of magnetic force. That was from 1852. He obviously was investigating magnetism since the 1830s at least, not earlier. And he says, I cannot conceive curved lines of force without the conditions of a physical existence in that intermediate space. What was Mr. Faraday saying? There's something there that I cannot identify. It was a little too early for that, right? Bill Gates wasn't born then. And so he was trying to figure out what was in that space. What did Mr. Maxwell say? He put this in his book, A Dynamical Theory of the Electromagnetic Field. He knew what a field was that region where something is occurring, but he says the following: field, this is his definition, okay? The space in the neighborhood of the electric and magnetic bodies. In that space, what? There is matter in motion. Matter in motion. A field is a region where there is matter in motion. It's an exotic type of matter, no doubt about it, but it's in motion. And you say, well, Bill, is that really true? Is there something moving in a field? I mean, the iron filings don't seem to move. They just stick to the magnet. There's nothing moving there. So what do you mean there's something moving in that region of space like Mr. Maxwell said? Okay, and here, let's prove it. You want truth, proof, evidence? Okay, let's do an experiment here. Here we put a magnet underwater. We're going to put a magnet underwater, and you can see that each one of the iron filings is drawn individually one by one. There is something moving in that region called field, magnetic field. Here it is. Okay, look at that. Okay, you can see the iron filings being pulled one by one towards the magnet. Something is twirling, something is moving in a region around the magnet, and we call that region. We refer to that region as a magnetic field, but a magnetic field is not a static thing. Okay? What it is, like Mr. Maxwell said, there is matter in motion. Matter in motion. You cannot avoid it. Okay, so what we need to do is identify what is that Mother Nature uses, because we're going to unify, remember, electricity with gravity. We're going to try to figure out, because what is electricity, what is magnetism? Well, we have electromagnetism, and electromagnetism, as according to Mr. Hertz, is what builds the electromagnetic wave known as light. So we have light and gravity, and we have to include electricity and magnetism within that context, okay? And so here's an experiment that will, in addition, unify quantum mechanics with general relativity, because general relativity, again, is the world of big, quantum mechanics is the world of the small. Okay, we have the Lunar Ranging experiment, done for many years. The project was shut down afterwards, a couple of years ago, I think. Here's the Lunar Ranging, okay? And you have what you have. You have a laser pointed from the Earth to a retroreflector on the moon. Okay, let's do it with waves, okay? Here we have the electromagnetic waves. What are you staring at? You're staring at vectors that are moving. What is a vector? Well, vector is just magnitude and direction. What are we talking about? Magnitude? A number. So you're talking about five whatevers, and they're moving a given direction. That's what those arrows represent. A whole bunch of arrows makes a field, and a field makes light. In other words, this laser made out of light, you're talking about vectors. So what are we talking about? We're talking about numbers. This is a quantitative description of what light is. It doesn't tell us what light itself is. Okay, okay, let's do it differently. Let's do it with particles. Here we go with particles. Okay, okay, so we go with particles. How are you going to unite? Because remember, the grand unified theory is about unifying light with gravity. Okay, we got light. How do you unify that with gravity? I mean, how does those particles that go from the Earth to the moon and back after they hit the retroreflector, how does that produce pull? How does that produce for the moon not to leave the solar system? That's the question you have to answer. Okay, and there's a bigger problem also with particles, in case you want to simulate light with particles, the laser with particles, and that's the fact that the moon is moving. See, if the moon was standing still, well, you can maybe still say, I shoot particles at the retroreflector, they bounce off, they come back to Earth. Great. Now let's move the moon. We're going to be moving the moon now, okay? Here it is. And this is what happens to the particles. The particles are going to have to describe a curve in space. Okay, you can see how that goes. As the Earth moves and moon moves, you have to shoot the particles where the moon is going to be in the next few seconds. Okay, see it here? We got 384 kilometers, 1,000 kilometers. That's almost 1.5 light seconds. Okay, so round trip, you're talking about almost 3 seconds. And by that time, the Earth is traveling 30 kilometers per second around the sun. The moon is traveling 1 kilometer per second around the Earth. Those are the speeds. And so you describe a curve. So here you're shooting these particles at the retroreflector. They have to trace a curve through space in order to hit the reflector to where the moon is going to be in 1 second, 1.5 seconds really, and then it bounces back and to where the Earth is going to be in 3 seconds later. Yeah, sure. What is this, ping pong? Okay, you see the problem. You got to shoot the particles where the moon is going to be, even if it's just a relatively short distance. Again, you're not supposed to point it directly at the retroreflector. That's my point. Okay, so this is the problem with that. Okay, that with particles. But again, even if you use particles or waves, that's great for light. Now unify that with gravity, because that's what the gut is. The gut is the grand unified theory. Okay. And so here we do it with ropes. This is the way science does it, rational science. Okay, we have the laser there, and what you have is actually ropes. We put only one rope. Obviously, we're talking about gazillions of ropes here, but we put one rope, and you can see what's happening. Nothing goes anywhere. All you have is a rope tying your laser directly to the retroreflector and back. All it does is twirl in place. We receive the signal at the atom that receives the thump, okay? And what happens? Well, let's move the moon around. What happens when we move the moon now? Well, you can see what happens. You have all these ropes, electromagnetic ropes, twined threads. Every atom from the moon is connected to every atom of the Earth. And so both of them can move anywhere they want. Light will never get lost because light can only travel along a rope. What is light? Just a torsion of the rope. It's not even any traveling. That's why it's so fast. Just twirl a rope in place and you'll find out that the signal travels, you could say, instantaneously. That's how fast light is. 300,000 kilometers per second. You can only explain it with something like a rope. Okay? A twined pair of threads, a DNA-like rope. Then you can explain the speed. Okay, so here we have an astronaut, and he's falling to Earth. Okay, here he goes. He's falling to Earth. How are we going to explain this? And again, remember that you not only have to explain it, you have to do two things. You're going to be uniting light with gravity. Okay, here we have gravity. You say, well, he falls to Earth because of gravity. Great. We have no explanation. All we have is a description. We're saying that's gravity that did it. Okay. So let's do it with force, which is what quantum mechanics would propose. That's what Newton proposed. He says there's a force. Okay, so let's go with the force. Here's the force. Force is pushing him down. So we have a concept called force, and it's pushing the astronaut down towards the Earth. Great. We're going to learn a lot with that. The word force. All you can do with force is describe. You have an equation. You say force is equal to gravitational constant G times mass divided by distance squared. That's just a description, a quantitative description. So far, you haven't explained anything. So by saying force, you're only giving me a mathematical description. Okay, let's replace that now with particles. How do we do it with particles? Here's the astronaut being pushed by particles. Great. So we have all these particles everywhere. What's the mechanism? And even if you have a mechanism, you can tell me how the astronaut being, for example, pushed by all these particles. Tell me how that relates to light. Because remember, you have to unify light with gravity. We have gravity, but where's the light? Okay, so that's the problem there. How do they do it in General Relativity? Well, there it's a little scary, okay? And here it is. Okay, we have warp time, okay? And there you have warp time. Okay, the guy, I guess, slides down that canvas. Bumpy ride there, okay? What the hell is that? How do you explain that the astronaut falls to Earth because, there's this canvas made of time, and it's waving around because you have to have waves. Remember, you have to have gravitational waves. How does that relate to anything? And there you have the waves, okay? How do we do it with ropes, with science, with The rope hypothesis is very simple. Every atom in the of the astronaut is bound to every atom on Earth. As he gets closer to the Earth, the ropes fan out. Period. We're done. Baby stuff. You don't need to go to college to understand this. Well, unless you've been brainwashed by the system. But otherwise, if you were an 8-year-old boy, you would say, "Well, I understand this is straightforward. Every atom in his body is connected to the Earth. As he gets closer, the ropes fan out. That gives you the acceleration known as gravity here on Earth. Obviously, on the moon, you would go at a different rate, and so on, in the sun as well." Okay, so you can see the comparisons between the establishment and what we propose here. Here's another one. Here's the spoon. We let go of the spoon. Now we're on Earth. We're no longer out there in space. So we're going to be looking at quantum mechanics, or you could say classical mechanics, if that's what you vouch for, okay, what you defend. Here we have a spoon. It falls to the floor, okay? So we say, why did that spoon fall to the floor? Okay, so what are we going to do? Use green pixies, as this fellow suggested? We're going to have all this green pixies push the spoon downwards. And then what do we do with the green pixies on the other side of the planet? When the Chinese man lets go of the spoon, the pixies move in the opposite direction? I mean, this is kind of very specific. You're saying here it does, but then how does it do it on the other side of the planet? Okay? How did we do it in science? Well, very simple. If every atom of the spoon is bound to every atom on Earth, as the spoon falls to the floor, the ropes fan out. See how easy it is to understand the mechanism. Now, whether you believe in this or not, that's your personal opinion. What we're saying here, I'm giving you a mechanism that you can sink your teeth into. The other ones can't give you a mechanism. And that's why mathematical physics doesn't deal with mechanisms and dismisses them as what? As philosophy. Okay, so here's what you got to do. This is your homework. Okay, if you want to do the grand unified theory, this is what you're tasked with. You have to unify particles with waves. What are waves? A bunch of vectors that are moving. Very scary stuff. What is a vector? Magnitude and direction. And they have these magnitude and directions moving sideways, perpendicular to the direction of the vectors. And there you have particles. You can assume that they're anything. You can assume that they're electrons, if that's what you want, photons, virtual photons maybe, tachyons, whatever you want to put in there. I don't care. Please unify these two proposals. How are you going to unify them? And so what they do is they elude the visualization because they cannot even visualize it. In fact, for the wave packet, who was it? Roger Penrose, Nobel Prize. What did he draw in his book? 2 books, by the way. He drew a corkscrew because he had no idea how to illustrate a wave packet. Okay, just a bundle of energy. But this is what you got to do. You have to unify the particles with the waves. Is there something you can do there physically? Absolutely not. Mathematically, which is the equation they're searching for, well, I don't know. I mean, first of all, we don't care, even if they find an equation, but I doubt very much you can find an equation that can unify first the particles with the waves, and then gravity with light. In other words, quantum mechanics and general relativity. Okay, how do we do it in science, in real science? Well, here you have it. Put it over here. See how easy it was? There it is. You have 2 atoms. They're bound by what we call the electromagnetic rope, a DNA-like mediator. And what it does is it twirls around. It torques. And it's these torsions that thump the atoms to which they're connected. And you receive the light that comes from the other atom, and the other guy receives the light that comes from your atom. That's what's happening. That's why it's almost instantaneous when that happens. Okay? Okay, and so give me a second here. Give me a second. I'll be back in a second. Okay, I'm back. This is what we are trying to do here. We're trying to unify in mathematics, right? What they're trying to do is unify Newton's gravitational equation together with Einstein's field equation. Okay, this is essentially what it is for gravity. Even if you could unify those, you could say that Newton's gravitational equation is Einstein's equation at the limit when it stands still, when everything's standing still. Okay, um, but that can be done. Okay, but look at the mechanisms. What does Newton propose? Well, he's suggested force, and he mediated that in his mind with particles. On the other hand, look at Einstein. What did he propose? Warp time. And I'm not sure how you can unify warp time with particles. Okay, that's the problem there. So the unification of the equations could be one thing that might be achievable. What you cannot achieve is the unification of the mechanisms. And then unifying this with light. Well, good luck with that one. You know, both from the point of view of equations, which at least quantum mechanics has been unable to do. Uh, but for sure, you cannot unify light with gravity out there in space. I mean, what you're going to have to do is explain why the Earth doesn't fly out of the solar system because it's held by what we call gravity to the sun. What's that got to do with light? And that's where the problem is. They cannot unify these two mechanisms to begin with, let alone the mathematical description. And here we have another problem we're going to throw on top of that because you have the gravity waves. Okay, remember a couple of years ago they proved that two black holes collided and they were able to pick up the gravity waves from those two black holes. The waving of what? And then this is the issue. The issue if gravity is made of waves, of some kind of waves, how does that pull if a wave is an outward mechanism? I mean, a wave is, you throw the stone in the pond, the waves, the ripples go outwards from where the stone fell. And so let's throw 3 stones in space. Here we go. Okay, here's the stones from the black holes, right? We'll call those the stones. And they create these waves and the waves move outwards. But then you have waves moving out from another pair of black holes and from another black hole. So these waves move outwards. Please tell me, please explain to me, give me a mechanism of how these waves that go outwards pull on each other. How do these waves from one pair of black holes there pull on the waves created by another pair of black holes? How do they pull on the other black hole? They're all going outwards. So the mechanism is irrational, totally irrational. You cannot visualize this. So whatever they proved, NASA again, or all these groups that are out there, these think tanks, they go out there and they say, look, we've proven it. We were able to detect gravitational waves. Yeah? So those were the waves coming towards us. How do those pull us? How do you know they're gravity waves? That's the issue. And so, mathematical physics does not have mechanisms. And so the question is, if they're describing something out there, how valid is their description if they don't know if it's a bird, a plane, or Superman? I mean, first you got to determine that before you can, put an equation to it. To have just a value and say, look, we know how fast it goes, but we don't know what it is that's moving. Maybe it's the Tasmanian devil that I showed earlier. Okay, maybe that's what's moving. You got to identify that first. Okay, so here are the problems, okay, with grand unified theory, and it's the grand unified mechanism the problems theorists must solve, okay, at least from a physical point of view. That's what we talk about here. First, we have to distinguish between explanation and description. We have to distinguish between mechanism and equation. Equation is just a description, a quantitative description. A mechanism is something that you can just watch. You want to know how the window broke. Okay, you see the stone go through the window, we're done. We know how the window broke. That's what we want to see. Something as simple as that. Kindergarten stuff. That's what Mother Nature understands. Mother Nature never went to school. She never learned math. We invented the math as a description, a language of descriptions for what Mother Nature does. And the only thing we can describe is, what we can see. We cannot describe or, quantify that which we cannot see. So we need to know, what's in that invisible world. That's what we need to detect, elucidate. And so what's the problem? The issue is that you have to explain action at a distance, specifically in the case of both magnetism and specifically gravity. Okay, action at a distance. Are you going to do it with particles? Because this is what quantum mechanics uses, even though the particles of quantum mechanics ain't particles. The particles of quantum mechanics are wave function collapses. That's what they are. They have a wave function collapses, it turns into a particle. And they call that a particle. So it's a concept that collapsed. And good luck with that one. No wonder they haven't incorporated gravity into the standard model of quantum mechanics. Waves, okay, waves are outward mechanisms. But what are waves? They're a bunch of vectors. So I guess that's the end of that. I mean, you cannot explain a physical mechanism with outward going waves, and for sure you cannot explain attraction with waves going outwards. And then you have the rope. So that's something for you to consider. If you want to pull on the donkey, you better have an elongated entity, a mediator between your hands and his neck. Okay, so I don't care if you use a rod, I don't care if you use a chain, coaxial, wire, whatever you want to use, but it better be elongated. It must reach from your hands all the way to the donkey. Then you can explain pull. If you do not put a mediator, you are, in effect, right, doing black magic. You're explaining with black magic. You're saying that you move here, your hand, and somehow, by remote control, the donkey moves towards you. Yeah, sure. And so, yeah, you have to reconcile waves with particles. You have to reconcile push with pull. That's what essentially the gut is. And again, you can't do it with one-way mechanisms because they don't attract. And you have to deal with, especially, intangibility and invisibility. Your task is to determine, to tell me what it is that is in that space between your hand and the donkey, between the earth and the sun, between the earth and the moon, between the Andromeda galaxy and the Milky Way galaxy. Why are we pulling on the Andromeda galaxy? How are we doing that? What is the mechanism? That's the issue. And if you can figure that out, hey, you get a Nobel for discovering the gut. Okay, because that's what the goal is. That's the Holy Grail, the grand unified theory of mathematics. Okay, we had some Moonies the other day, and they had some points they raised. What is a Moonie? Well, a Moonie is a person who believes that humans never stepped on the moon. Okay, so we have these Moonies, and I can only tell you that, they gave me a little tinge of doubt when I found out how Neil Armstrong answered in that he gave, there was a conference, and he talked to all the people from the press, okay, and he was not very gung-ho about him having stepped on the moon. And that made me wonder about Neil Armstrong. I thought that was kind of strange. But just because he was strange, it doesn't mean I'm going to throw the baby with the wash water. It doesn't mean I'm not going to believe that man did not go to the moon. And I'm saying that the best way to deal with this subject for people who are rational on both sides of the issue, because there are people who simply don't believe, but I think they are quite rational anyways. But this is the issue. The issue is, why don't we sink our teeth into something that we can all verify to some degree? And that is the ISS, the International Space Station. It's flying around 15 times a day, every hour and a half, around the world. Okay? And anyone who's got a pair of binoculars or a telescope should be able to follow the path that is published by NASA and locate that thing up in the air. Okay, you should be able to focus, especially on a clear day, you should be able to focus and see the ISS out there. Now, if you can focus your binoculars or your telescope on the ISS, you'll realize that that is a big monster. This is not a little 2x4 toy that they sent out. It's not a little balloon. You're talking about a monster out there that's flying around the Earth. And so the question is, how did they put that thing up there? Did they take one day just said they had a headache and they said, why don't we send a rocket with all this stuff up there? Is that how they did it? No, there had to be steps, many steps, before they could build that thing up there, this monster, and make it orbit around the Earth. And if we have the technology to send piece by piece up there over a period of 10 years, build the ISS up there, and make it orbit the Earth, then you have to say, well, it's not all fake news. Okay, and it's not like you should believe anything. You should throw the baby out with the wash water. There is something out there, and we have to identify it. If you identify it, you have to believe that there were steps that humans took to get that thing up there in the air. Okay, so one fellow says that we could reproduce some of this stuff in Hollywood. Okay, so he says the following: JFK boldly proclaimed to the world the U.S. would successfully put a man on the moon and return him safely to Earth before the end of the decade, in the 60s, right? And he did it, okay, or apparently that was the goal, right? Charged with executing that mission, it would be a dereliction of duty not to game out what failure might look like. Dead U.S. astronauts orbiting the moon or Earth for decades is a scenario to be avoided at all costs. Okay, he says, if the best in the 1960s had the know-how to put a man on the moon, Hollywood's best of the era could realistically recreate the successful mission. Always have a plan B. Yeah, I'm not saying that you could not reproduce this in Hollywood. Maybe not at the time. I'm not so sure they could reproduce what I showed the other day, which was Buzz Aldrin, flipping, what was it, a flashlight around? I'm not sure they could have done that in 1969 in Hollywood or in the best of studio on Earth. But let's concede it. Let's forget about challenging it. Let's concede it. I said it the other day. Everything that we've done on the moon can be just as well be done in Hollywood. We're done. I'm on record, okay? So how do you distinguish the real thing from the fake one? How do you distinguish whether it was done in Hollywood or whether it was done on the moon? And the answer is you probably can't. Not today, at least. Especially, when you look at everything in retrospect. And so all you can have is some conspiracy theory saying, well, the government's fooling us, they did this, they did that, why did they hide this, why did the tapes disappear, and why is the shadow here wrong, and you can do a million analysis, okay? And the question is, you're always going to end up with the same answer. The answer is, we could have just as well done it in Hollywood as on Earth. And does that mean that we did not go to the moon? So that's a question for you to ponder. Okay, here's another fellow. He put the Columbia impersonators. Columbia was the one that blew up in the air, okay, up there, never made it. And all these people, they say, are still alive. They got their names. They say their faces are very similar. And so this is what they put out. And so, yeah, all you can do is talk about conspiracies. That's about it. This does not prove anything, but this is what people dwell upon. They say, oh, I saw this person again. They think this is like 9/11, where some of the pilots ended up being alive in Saudi Arabia, and then the U.S. government said, well, same name. Okay, also a pilot, just by sheer coincidence. A very common name like Smith, Okay, I don't know. A lot of this stuff is fakery on the people who actually put the pictures out there, but people never investigate where the pictures came from. And so, what have we learned? We haven't learned anything just by looking at these pictures and saying, oh, they're still alive. Are you sure? Or are you going to believe the guy who put the pictures out there? Did you ask him where he got them? I mean, you can go on and on. Okay, another fellow says, the ISS, we see something in the sky, sure, but how can we verify what it is? Okay, let's start with its altitude. How do we do that? I don't think people deny that you see something. The thing in question is if the thing you are seeing is ISS, where the ISS footage is recorded from, or I guess he was asking a question there, I guess. Anyways, he says, which is highly unlikely as it's kind of demonstrated that they are mixing several different techniques together. And again, all I can tell you is, uh, you know, is there an ISS? First of all, please verify that first before you open your mouth, because we can talk all day about, conspiracies, and we're not interested in that per se. The first thing we want to establish is there an ISS to begin with out there that everyone can verify at home, or maybe with some friend who's got a telescope or whatever. You can verify this. And if it's out there, you got, at least you block that base. You say, I covered that base. Okay, so it's either out there or it ain't. One of the two. It can't be both. Okay, and that's something anyone can verify out there without just spinning their wheels. And so this is where I ask people to start. Start by saying, is there an ISS? If there is, we can go to the next step and say, are there people in the ISS? Are they floating around? And here's one fellow who's dead set against that. He says there's a problem with safety, especially with a lady there who let go of the bubble of water, and then she swallows it. And this fellow says, "Oh, how could you do that? That's so dangerous. It could kill them all." And another person says, I think it's this one also, says that someone could perforate one of these stones that the sun throws at us together with the solar wind, and throws the stones at us. It goes right through the ISS, and suddenly you have a leak. And these people are, even without helmets in there, they would instantly die. Why would they be without helmets, without spacesuits, without anything inside the ISS when it's so dangerous, when anything can go wrong, And it says, how long do the astronauts have to get into a pressured suit if the ISS has a leak? In other words, let's say something suddenly punctures the ISS. Do they have time to put their helmets on and all this? In fact, I think when they sleep, they even take their suits off. They kind of sleep standing up. Obviously, we don't know. However, there is a person who decided to discuss the issues of pressure and possible failures with anyone who wanted to listen. He was quite firm that there was something amiss with the safety procedures on the ISS. Okay, do you put a helmet on or even a parachute when you go on an airplane? I mean, anything can happen on an airplane. In fact, I think it's more likely to happen on an airplane than out there in space, where you have, you've got a lot more vacuum up there, right? You're in a level of vacuum much higher than the Earth. So here on Earth, just about anything can hit a plane. In fact, there's been planes that have been hit by birds, flock of birds that went into the engines. They've had all kinds of problems with birds. But anything can, a stone out of nowhere, volcano maybe erupting somewhere and throws a stone at the airplane. Suddenly it goes at such speed that it punctures, the wall of the airplane. Are you prepared to put a helmet on? Or are you going to wait for the mask to come down? Or, what procedures are there? And again, I'm saying that, the likelihood of that happening is so remote that I don't think the astronauts have to worry about it, especially about drinking water, a bubble of water floating around. Someone in there said, it's incredible that she would have that. It could oxidize the wires and everything. I mean, come on. What are these people thinking about? Okay, and then another fellow talks about the construction of the ISS. He says, the ISS is the biggest marvel construction of humankind, and no video evidence of its construction exists. First of all, they built it over 10 years. That's the official version. You don't have to believe it. Maybe it's fake news, but that's what they say. It's built over 10 years. I'm not sure they're going to take the trouble to go up there and with a camera and say, okay, Joe, what are you going to put today? I'm going to put the left wing. Okay, so they put the left wing and the guy films it. Then the next day they do something else. Then you have to think about, the fact that they took a lot of these parts with the shuttles. So the shuttle went up there, took the part, and then came down. And so they're going to film every little trip up there for every little part that they built on the ISS. I mean, I don't think so. I don't know. I'm not sure it's, at least I don't think it's an argument against the building of the ISS. But yeah, maybe there is, maybe some part was filmed. I don't know. Maybe there is a film of one of the parts, or maybe the original part that they put up there. I can't tell you. But I don't think it denies that there's an ISS up there. Again, don't tell me how it was built. Tell me if there is something up there to begin with, because if there ain't, then we don't have to worry about anything related to the ISS. Okay, another fellow says, show me a full orbit of the ISS, uninterrupted film from on board. He wants the guy 24 hours, or I'm sorry, it'd be an hour and a half because it's every 15 minutes, and the guy filming around, right? Well, we can do that in Hollywood. In fact, they did say that the Apollo 11 trip was filmed. I mean, one of the arguments out there, one of the theories, one of these people who objects, who thinks it's a hoax. They said that it was filmed in Houston, where they have this globe that they made of the moon, which they built exactly like the moon with all the surface features, etc., which they filmed when we sent the lunar orbiters up there. So we filmed that from everywhere, from every side. We filmed the moon even from the dark side. They built this globe, which is an exact replica, of the moon, and they could have filmed there as well. So we can do the same thing with the Earth. I'm sure we can film all around the globe that we have in front of us and say, oh, this is from the ISS. So, I mean, how can you tell the difference between the guy who films it from the ISS and the guy who films it here on Earth? I mean, would that prove to him that there is an ISS out there? Okay, so again, a lot of these arguments don't hit the mark. They don't hit the mark because I think what you got to do is first determine whether there is an ISS floating up there, orbiting the Earth. And if there is one, well, at least we covered first base. Then the next question is maybe, another of the questions would be, are there people working in there floating around in not zero gravity, because you still have gravity, but remember that thing is, you're floating in that thing because, again, you have no gravity against the walls or anything. You're not kicked around, okay? So, again, first let's determine those two. And then whatever argument you come up with against Apollo 11 having landed on the moon, the issue is there a difference? Can you tell me the difference between landing on the moon for real and doing it in Hollywood? If you can tell me the difference, hey, I'll give you $1 million. I'll buy you a beer, okay? If you can't tell me the difference, well, then you don't have an argument against the fact that we did not land on the moon. Okay, let's move on to the questions people made, and some of them were related to the subject matter I brought up the other day, which was a concept. What is a concept? And we had all kinds of questions on that. Here we have one fellow says, quote, a concept is two objects, unquote. Well, not real. That's not what I said. Okay, so he's putting words in my mouth. He's saying a concept is two objects. Now, I could have said that off the cuff, and so he took it, he just hung on every word. No, I made it clear what a concept is. It's a word that invokes or embodies two objects. Okay, that's not exactly what he put there. A concept is two objects. No, not true. Okay, so he said, clearly you said nonsense. Okay, yeah, if you put a scarecrow there and want to knock it down, hey, knock yourself out. Maybe you meant two objects in relationship to form a concept. Okay, again, this fellow's English is not up to par, okay, not the best, but his understanding is even worse, okay? I took an apple and I placed it on the table in the kitchen. Then I took another apple and placed it next to the first one. Now I have two apples on the table. I have a concept of apples. Okay, he said relationship equal concept, synonyms, that's what I'm saying, okay? You can't, the word concept is essentially a synonym of relationship. That's why you need to have two objects. And I use the word that. I showed that as a preposition, as a conjunction, etc. The word that already embodies or implies two objects, a relationship between two objects. Because when you talk about that, you're referring to implicitly to this. The fact that two objects are or have a relationship of connection, of dependence, generates a or forms a concept. And here you have the definition, okay? Here's the definition. Concept, a word that invokes or embodies two objects or two words treated as objects. And I like the example of the word universe, which a lot of people say, oh, a universe is a thing. And when I tell them it's a concept, they say, oh, so we live within a concept? And so we have to answer this for people to understand what we're referring to here. Universe, what is the word? Matter and space. So we're talking about atoms and nothing. That's what universe is. We're treating nothing or space temporarily as an object. Again, two words, treated as objects. Here we're treating space as if it were an object. We're saying there's matter or atoms. And we have this other thingy, which is a non-thingy, a nothing, but we'll call it a thingy now. We have two things. We have the atoms and we have nothing. Object, that which has shape. We should take that doesn't out. That, any word that you can imagine. So whenever we say that, we're referring to any word in the dictionary. What is matter? Many objects. That's what matter is. And space, that which has no shape. In other words, nothing. So space is momentarily treated as a container, okay? And of course, it's not a container, but we treat it as if it were a container. We're treating it as an object. So concepts such as universe and space can be neither finite nor infinite. There is no concept that has shape, so you cannot say that the concept, in this case universe, or in this case space, is a thing, okay? So the word concept, again, a word that embodies or invokes two objects. It tacitly alludes to two objects. Okay, here we have concept versus the object. Okay, we have this. No concept has shape. All concepts are relations. They're comparisons. But made by whom? By us, by humans. Objects we point to. Concepts we define. Okay, so you don't define the word chair. You point to it and name it, say chair. And now the ET understands your language. Okay, the Klingon now knows what you're referring to every time you say chair. Okay, you can't do that with concept. You can't point to energy. You can't point to love. You can't point to mass. You can point to what has mass, like the elephant, but you can't point to mass itself. You can't point to weight. Okay, and objects have contrasts. Okay, concepts have antonyms. Okay, concepts have synonyms and antonyms, but objects have contrast. They better have contrast if it's an object. And so the question there, what contrast are you going to put for space? What's outside of space? Where does space end and whatever continues? That's what you got to answer. And of course, you can't do that with space. Space is the contrast to all objects. It's the contrast of all objects. Space is also the name we give to the antonym of object. In other words, nothing. Nothing is the opposite of something. When you point to space, the dark stuff there between the Earth and the moon, right? You are implicitly treating space as an object. Okay, so that's the context of the word space in the context of universe, which is a concept. Do we live in a concept? Do we live within a concept? Do we live in the universe? The answer is no. We don't live in a concept. We don't live within a concept. Universe is matter and space. We don't live in, but we form part of the matter of the universe. We are made of atoms, just like everything else that is made of something out there. Okay? And so you can't say that we live in the universe. We are the matter. We form part of the matter of the universe. That's the way we have to look at this. And we are not supposed to treat space or the universe. Wrong to put an article in front of that in physics. But we do not live within, like if we're inside a container. Okay, that's not the notion that we should have of space or of the universe. The way we have to look at it is we form the matter of the universe. Okay, here's another fellow, also relates to the definition of concept. Concept refers to those words, terms, and prepositions which assist us in the perception and description of the world, shapes, colors, quantities, measures, temporal words, positional words. And again, all they do is copy and paste. Where do they copy it from? They copy it from the ordinary dictionary. This is not a scientific definition, so we cannot use this in science. First of all, it's too verbose, too many words. And the more words you put in a definition, the easier it is to tear down. Look at the word life, which I analyzed some time ago. And they say, well, if that which reproduces, which grows, which ages, etc., right? And so, my grandmother doesn't reproduce anymore. My aunt never reproduced. Were they alive? So you can see how easy it is to tear definitions that have so many predicates. Okay, you got to make the definition as short as you can. And this one, you can see the word concept here. It's got so many if, ands, and buts that it looks like one of those laws that they make, Congress makes, So yeah, this is no good. You can't use this definition. Easy to tear down. And again, that's from ordinary speech. Okay, here's another fellow who gave it a shot, and I'm not sure he pulled it out of a dictionary, but it says concept means thought conceived by the mind. Love that one because he says concept is conceived. Okay, a concept is a conception. Okay, good. Love it. Yeah, you can't use synonyms to define words, and that's what all these people do. They never learn how to define words scientifically. The first thing you have to avoid is antonyms and synonyms. You cannot say, what's the definition of horse? Well, it's not a dog, and it's not a cat. It's not a fish. But yeah, you're going to go through all the animals in the universe? I mean, you can't define things in the negative, okay? Okay, changing a little bit the subject, fellow talks about knowledge and belief. People don't like me saying that knowledge is belief because it destroys their religion. So here it is. He says, no equal belief, completely wrong. Okay? Wrong according to whom? See, wrong means your opinion. What's wrong to you is right to someone else, to your neighbor. Okay, so we look it up. Knowledge, what is it? Justified true belief. Big belief there. What is justified? Also belief. Justified means you. You justified it. So justified by whom? True according to whom? And believed by whom? By the Pope. I mean, who? Who believes it? Who justified it? It all comes down to belief. So when you know something for sure, when you are certain of it, when you are convinced, it is nothing more than your opinion. Belief. Keep that in mind. Knowledge is belief. There is no difference between knowledge and belief. People want to think that they know. And again, like I told this fellow, I said, NASA proved they know. Proved it through an experiment. They have to know, right? And the official version is that Earth, when it spins, drags space and time around itself. Okay, so they know it. And he said, well, I don't believe that. Well, what do you mean? It's knowledge. They know it. What do you mean you don't believe it? Yeah, we all have problems with knowledge because your knowledge is different than my knowledge. Okay, here's another fellow who says, all objects have shape. Okay, but not all shapes are objects. Aha, well, give me an example. Don't give me a statement. Give me an example. Show me a shape that is not an object. Something that has shape that is not an object. Okay, and of course, if we define object as that which has shape, you're going to have a little trouble with that. Okay, all you're going to have is an opinion. Opinions, yeah, sure, you might have opinions and say, look, I don't think that a square is an object. I don't think a line is an object, for example, or a point, right? And I see something in front of me. It's got shape. So yeah, point, line, and plane, you could say, something like a square or a circle. Yeah, they're objects. They're objects because they have shape, and that's the definition of object, that which has shape. We're done. Now, if you have a better definition, start with the definition, and then show me which, like he says there, not all shapes are objects. Show me that your definition meets that criteria there. Okay, that's what you got to do. That's your homework. Okay, and here we go with another one. Fellow says that science has all to do with what? With predictions. Okay, let's find out. He says, if science isn't about making accurate predictions, then science is lame, and we shouldn't do it. Okay, let's not do science because, the mathematicians say it's predictions. And I'm saying that predictions have nothing to do with anything. Let me tell you why. Very simple. I make a prediction. There's going to be, an eclipse tomorrow. Okay? I make a prediction. Turns out that there is an eclipse. So far, all I did was give you a description. Now, if I can explain why, what caused, or what the mechanism is of an eclipse, if I can explain to you, it means I have some experience with eclipses. Where did I get this? How did I have an explanation for it? Well, the explanation obviously is because I had some experience with it, and explanations only have to do with the past. Okay, it means I already saw the movie, at least in my mind, I visualized it. So an explanation has nothing to do with the future, with predictions. They're on opposite sides of the now, of the line that divides the future from the past. Explanations belong exclusively to the past. Predictions belong exclusively to the future. If you just do a prediction, all you did was describe. If you can explain why something is going to happen, it's because you have some, what was it called? Knowledge? Some belief? No, some explanation. You've already watched the movie. You visualized it, and that means you have some experience with it, and that's the past. So as long as you keep it to prediction, you're okay. We won't hurt you. As soon as you give me an explanation of why, you're in trouble, because now you're talking about the past and not the future. And so it's funny when the mathematicians say, we can predict the original conditions of the Big Bang. That happened, 12.8 billion years ago? 13.8 billion years ago? Yeah, we can predict. Yeah, sure. Okay, and finally, a fellow he says, I recently saw an example in a video where a scientist explained 5 different methods of gravity to children of different ages. She always said, pull. But how the mechanism of pull works, I asked. She didn't really explain. The children's brains were overwhelmed trying to adapt to a non-visualization. The youngest ones didn't succeed, but the older ones had already adapted to the non-visualization. They said, don't even waste your time. That's a tragedy, because visualizing is a human trait that we have stored in our brains from our earliest ancestors, and this trait, as I said, has been lost through school. Yeah, see, if you teach a child to visualize, instead of to read a book and say, just memorize what's on page 45 and it'll be on the test. If you ask them to visualize a mechanism, they would learn physics, because they would have to figure out, if they can't visualize that, then they have a problem. And you say, look, make a movie of it, make all these drawings, motion pictures, make a lot of pictures, put them in motion. And then he can visualize the mechanism of whatever. But if he just reads and memorizes, or just listens to the teacher recite some poetry, and he memorizes that, well, all he's doing is feeding his brain on stuff that later he can't come out of so easily. That's the effect of that. Yeah, you have to visualize, especially in physics. If you cannot visualize in physics, you do not have a theory. Theory of physics is a mechanism, and a mechanism is done with objects. And if there are objects, there should be no reason for you not to visualize it. Make a movie and visualize it. With that, I'll see you probably next Sunday, folks. And maybe I can get rid of this stuff that I had in my chest by then.